Good morning, all of you. Welcome to C. Jain Zone. So, in the previous lecture, we have completed hydrogen compounds up to preparations of hydrogen peroxide. Now, in this lecture, we are going to discuss physical properties and chemical properties and use of hydrogen peroxide, and also how to express concentration of hydrogen peroxide, strength of hydrogen peroxide also, and then we can wind up the class. So, let us start properties of hydrogen peroxide. So, in the pure state, hydrogen peroxide is almost the pure state, hydrogen peroxide is almost colorless, very pale blue color liquid. Very pale blue color liquid. It is almost colorless, and it melts at 272.4 kelvins and has a boiling point of 423 kelvins extrapolated. It is miscible in water in all proportions and form hydrates. Hydrogen peroxide is miscible with water and alcohol and ether in all proportions. Also, not only water, it also alcohol and ether. Hydrogen peroxide is miscible. Miscible means mixed with water, alcohol, and ether in all proportions. With water, it forms hydrate, that is H2O2 dot H2O, melting point 221 kelvins. A 3% solution is marketed as 100 volumes of hydrogen peroxide. A 3% solution of hydrogen peroxide, 3% solution of hydrogen peroxide is marketed as 100 volumes hydrogen peroxide, indicating that at STP is marketed as 100 volumes of hydrogen peroxide, 100 volumes of hydrogen peroxide at STP, indicates that STP 10 volumes of oxygen are liberated per ml of solution. It indicates at STP 10 volumes of oxygen gas, 10 volumes of oxygen gas is liberated per ml of this solution, ml of this solution. So this is called 3% solution of hydrogen peroxide. So these are the physical properties of hydrogen peroxide. On decomposition, hydrogen peroxide decomposes to form water and oxygen gas. Water and oxygen gas. So the 3% hydrogen peroxide solution is marketed as 100 volumes of hydrogen peroxide. It indicates at STP 10 volumes of oxygen is liberated per ml of this solution. So these are the physical properties of hydrogen peroxide, and more important, since the association of the boiling point is very high for hydrogen peroxide due to hydrogen bonding. In water, how the hydrogen bonding is present, in the same way hydrogen bonding is present in hydrogen peroxide also. It is more when compared to water, so that's why its boiling point is 423 kelvins greater than water, that is 373 kelvins, because of extrapolated. What is this extrapolated? Because it forms hydrogen bonding, due to hydrogen bonding. Next, continuation. So now chemical properties of hydrogen peroxide, let us see now. Hydrogen peroxide is in both acidic and basic medium, acts as an oxidizing agent as well as the reducing agent. Very, very important. Hydrogen peroxide acts as oxidizing agent as well as reducing agent. So in acidic medium, it acts as powerful oxidizing agent as well as, and in basic medium, it acts as reducing agent. So let us see some equations. The following reactions will give a clear picture. Oxidation reactions of hydrogen peroxide, very, very important for competitive exams. They'll ask oxidation reactions of hydrogen peroxide. Hydrogen peroxide oxidizes black lead sulfide to white lead sulfate. The reaction is PBS. Here I write clearly PBS plus 4H2O2. 4 molecules of H2O2 gives rise to PbSO4 plus 4 molecules of water. So this lead sulfide is white in color, and this lead sulfide is black in color. So it oxidizes black lead sulfide to white lead sulfide. It oxidizes potassium iodide to iodine. Potassium iodide on reaction with hydrogen peroxide forms potassium hydroxide plus iodine. So it oxidizes potassium iodide to iodine. The oxidation state of iodine is -1 and it is 0 here. So increase in oxidation number, which indicates that is oxidation takes place. So hydrogen peroxide is good oxidizing agent in acidic medium. It oxidizes black lead sulfate to white lead sulfate and also oxidizes potassium iodide to iodine, and it also oxidizes hydrogen peroxide also oxidizes nitrate ion to nitrite ion, nitrite to nitrate plus NO2 minus gives rise to, or you can say KNO2 directly. Here I'll write the equation pattern by writing ionic pattern. So I'll write the equation pattern only KNO2. So it forms water plus potassium nitrate. So here it is nitrite and here it is nitrate. This is equation 3. Next, equation 4. Equation 4. Hydrogen peroxide oxidizes sulfide to sulfur. Hydrogen peroxide oxidizes sulfide, that is hydrogen sulfide, to water molecules, 2 moles of water plus 1 mole of sulfur. So it oxidizes sulfide, hydrogen sulfide to sulfur. This is the fourth property. Next, fifth property. Hydrogen peroxide oxidizes ferrous sulfate to ferric sulfate. Hydrogen peroxide. So fifth property I'm writing here. You can see here. Hydrogen peroxide with acidified medium, acidic medium, that is sulfuric acid, it plus 2 moles of FeSO4. So in acidic medium, it forms ferric sulfate, ferrous sulfate to ferric sulfate, Fe2SO4. Here ion is +2 state and here it is +3 state. So ferrous sulfate along with water. So this is called oxidizing properties of hydrogen peroxide. Oxidizing properties of hydrogen peroxide. So hydrogen peroxide oxidizes black lead sulfide to white lead sulfate. It oxidizes hydrogen sulfide, oxidizes potassium iodine to potassium iodine, potassium iodide, potassium iodide to iodine. It oxidizes potassium nitrite to nitrate, potassium nitrate. It oxidizes sulfide to sulfur. It oxidizes ferrous sulfate to ferric sulfate. So these are the important reactions of hydrogen peroxide regarding oxidation. Next we will see it oxidizes nitrites to nitrates. So NaNO2, sodium nitrite or potassium nitrate on reaction with hydrogen peroxide forms sodium nitrate plus water. It oxidizes potassium ferrocyanide. So potassium ferrocyanide K4 FeCN taken 6 times plus H2SO4 plus H2O2 forms potassium ferricyanide plus sulfate plus water. It oxidizes sulfides to sulfates. So these reactions already we have given. Sodium sulfide to sodium sulfate. And it oxidizes chromium 24 in acidic medium to chromium peroxide. So chromium oxide to chromium peroxide. Here it is called chromium peroxide. Chromium peroxide. So these are the important oxidation reactions of hydrogen peroxide. Next, continuation. Next, bleaching reactions. Bleaching reactions of hydrogen peroxide. Next, we'll write reducing properties of in alkaline medium, reducing reactions of hydrogen peroxide. Very, very important chemical properties of hydrogen peroxide. Definitely, they'll ask in the examination. So, bleaching reactions, it bleaches. Hydrogen peroxide bleaches silk, wool, cotton, and hair. So, hydrogen peroxide changes to hydrogen water plus nascent oxygen. This nascent oxygen attacks the colored matter and makes it colorless. So, hydrogen peroxide releases nascent oxygen. Hydrogen peroxide releases nascent oxygen, that is also called as just bond oxygen, which attacks the coloring matter to colorless. So colored substance combines with nascent oxygen and forms colorless. This is called the bleaching action of hydrogen peroxide. This is called the bleaching action of hydrogen peroxide. Next, continuation. Some more important reactions I would like to discuss. Now, reduction reactions of hydrogen peroxide. Let us see now. Since oxidizing properties we have done, now we have to see reduction reactions of hydrogen peroxide. It reduces barium peroxide to monoxide. So barium monoxide, barium peroxide on reaction hydrogen peroxide forms barium oxide, that is barium monoxide plus water plus oxygen gas. It reduces ozone to oxygen. So ozone on reaction with hydrogen peroxide, it forms water plus oxygen gas. It reduces alkaline potassium ferricyanide. So potassium ferricyanide to potassium ferrocyanide is called ferrocyanide. Ferrocyanide. And this is called ferricyanide. Ferricyanide. So in all these cases, reduction takes place, reverse of the previous reaction. So that is decrease in oxidation state, because oxidation state of oxygen is -1 here, and here it is -2. So ozone is oxygen state, ozone 0, so it changes to -2. So decrease in oxidation number. In all the cases, decrease in oxidation number takes place. So ferric cyanide to ferrocyanide. Here it is +3, and here it is +2. So oxygen state of ion is decreased. So this is called reducing nature of hydrogen peroxide. Some more reactions I would like to add. Hydrogen peroxide reduces acidified solution of manganese dioxide. So H2O2 on reaction with manganese dioxide plus 2H plus, that is in the presence of acid, it forms manganese sulfate. Manganese sulfate. So here it is manganese dioxide Mn plus 2 manganese sulfate. Even if we take H2SO4, so in place of this H plus, we will take H2SO4. So it forms manganese sulfate along with two water molecules. So manganese dioxide to manganese sulfate. This is again reduction. Reduction takes place. Hydrogen peroxide. Next reaction, fourth reaction, hydrogen peroxide combines with NH2OH, that is amine, and forms oxygen gas plus ammonia plus water. So it reduces. These are all reducing natures. NH2OH to NH3, NH2OH to NH3. That is NH2OH is called what? Amine, hydroxylamine, hydroxylamine. Hydrogen peroxide reduces hydroxylamine to ammonia. Hydrogen peroxide reduces ozone to oxygen. Hydrogen peroxide reduces halogens to halogen acid. So hydrogen peroxide, again I'm writing one more equation. Hydrogen peroxide combines with halogens. It forms 2 moles of halogen acids plus oxygen gas. So this is nothing but reduction reactions of hydrogen peroxide. So in these reactions, hydrogen peroxide acts as reducing agent. In this reaction, hydrogen acts as reducing agent. So that is in acidic medium and basic medium. Now we have seen in both the reactions in acidic mediums. Now we'll see the reactions in, it reduces alkaline potassium permanganate, alkaline potassium ferricyanate to ferrocyanide. So in basic medium we have done, as well as acidic medium. So these are the important reactions of hydrogen peroxide. Important reactions of hydrogen peroxide. Let us see next now. Next concept. Why hydrogen peroxide is stored in plastic containers? This question is very important. Hydrogen peroxide decomposes when exposed to sunlight. This process is catalyzed by the traces of alkali metals. Therefore, hydrogen peroxide is stored in wax-lined glass or plastic containers and kept in dark. It should also be kept away from dust particles, because dust can induce explosive decomposition of this compound. So hydrogen peroxide is stored only in plastic bottles because when exposed to sunlight, this process decomposes. Hydrogen peroxide decomposes to form water and oxygen gas. That's why to avoid decomposition of hydrogen peroxide, we have to store hydrogen peroxide in plastic bottles. Very, very important concept. Next continuation. So how to determine volume strength of hydrogen peroxide? This is very, very important concept. From this also you will expect a numerical. So how to determine volume strength of hydrogen peroxide? 10 volumes of hydrogen peroxide means 1 ml of hydrogen peroxide gives 10 ml of oxygen gas at HTP. This is a standard comparison. 10 volumes of hydrogen peroxide means 1 milliliter of hydrogen peroxide, which gives 10 ml of oxygen gas at HTP. Means hydrogen peroxide on decomposition gives rise to what? H2O plus oxygen gas. So when you decompose 1 ml of hydrogen peroxide, it gives out 10 ml of oxygen gas. This is called the standard comparison. From this, we can estimate the volume strength of hydrogen peroxide. So weight percentage if we take, let us consider 10 volumes of hydrogen peroxide. 2 volumes of hydrogen peroxide gives 2 moles of water and 1 mole of oxygen gas. It means 2 volumes means hydrogen peroxide, its weight is 34. So 34 is the molecular weight of hydrogen peroxide. Molecular weight of hydrogen peroxide is 34. So 68 grams of hydrogen peroxide gives 22.4 liters of oxygen gas at HTP. So 10 liters of oxygen is given by, so amount of hydrogen peroxide is equal 10 into 68 by 22.4, it is 30.36 grams. So 1000 ml of H2O2 gives 30.36 grams. So 100 ml gives 30.36%. So 100 volume of H2O2 or 3.03%, 036%. This is 3.036%. 3.036%. Hydrogen peroxide is known as perhydrol. What is perhydrol? 3.036% of weight by weight of hydrogen peroxide. Weight by weight of hydrogen peroxide is called as perhydrol. Very, very important. This perhydrol. This is where strength of hydrogen peroxide, volume strength of hydrogen peroxide has been calculated. So just by applying mole concept. So let us see how to estimate the strength of hydrogen peroxide, and then we'll take one numerical based on strength on hydrogen peroxide we'll take. So in terms of percentage, weight by weight percentage, this is the 3% hydrogen peroxide is called as perhydrol. 30% hydrogen peroxide or 3%, 30%. Simply you can take it as 30% only. 30% hydrogen peroxide, 30% weight by weight of hydrogen peroxide is called as perhydrol. This definitely they'll ask in the objective. Next concept. So molarity of hydrogen peroxide. To calculate, how to calculate molarity of hydrogen peroxide? To calculate molarity, let us consider 10 volume of hydrogen peroxide. M is equal to weight into 1000 by gram molecule weight into volume in milliliters. This is the formula for finding molarity concentration. Weight by gram molecule weight into 1000 by V. So molarity of hydrogen peroxide is equal to 30.36 by 34, that is 0.989 molarity. So normality of hydrogen peroxide, that is 1.78 normality. So into 2. Therefore, we can say when molarity is given,  to find strength of hydrogen peroxide, to find volume strength of hydrogen peroxide is equal to molarity into 11.2. When normality is given, to find volume strength, is equal to normality into 22.4, 5.6, sorry, molarity into 5.6, normality into 11.2. Molarity, normality into 11.2. So in this way, we will calculate normality and volume strength of hydrogen peroxide by using molarity and volume normality. So 30% is perhydrol. 30% strength of 100 volume hydrogen is called perhydrol. So let us see questions based on this, how to calculate. So I'll take new slide and write some more important points of this session. So questions based on volume strength. Questions based on volume strength of hydrogen peroxide. Let us start now. Questions based on volume strength of hydrogen peroxide. So I'll take one example right now. Calculate, question number 1. Calculate the number of moles. Calculate the number of moles and weight of oxygen produced of oxygen gas produced on heating 1.12 liters of 10 volumes. 10 volumes. If they ask 10 volume, you have to take 3%. 30 volume means 10 volume strength of 10 volume strength of hydrogen peroxide at STP, standard temperature and pressure. So this is the question. Now I'll write the solution for this so that you can understand how you will get questions based on this. So 1.1 liters, 10 volume strength. 10 volume strength means, so here volume of oxygen gas at STP is equal to volume of oxygen gas at STP is equal to volume of hydrogen peroxide into volume strength of hydrogen peroxide. Volume strength of hydrogen peroxide. This is the formula. So it is nothing but volume of hydrogen peroxide is given as 1.12 liters into volume strength of hydrogen peroxide is 10 volume strength. So it is equal to 11.2 liters. So number of moles of water at STP, number of moles of oxygen gas at STP is equal to, so 22.4 liters is 1 mole. So 11.2 liters means 11.2 liters by 22.4 liters, it is equal to half mole. So half mole is equal to weight is equal to how much? Weight is equal to 16 grams. Weight is equal to 16 grams. That's all. So 0.5 moles, weight is equal to 16 grams. So calculate the number of moles and weight of oxygen produced on heating 1.12 liters of 10 volume strength of hydrogen peroxide STP. This is model number 1. So to calculate, first we have to calculate volume of oxygen gas at STP. So volume of oxygen gas at STP is equal to volume of H2O2 given into volume strength of hydrogen peroxide. So volume of H2O2 is given as 1.12 and 10 volume strength of hydrogen peroxide. So volume strength of hydrogen peroxide is 10 volumes. So it is nothing but 1.12 in 10, that is 11.2 liters. So for 11.2 liters at STP, the weight of oxygen will be 16 grams and number of moles will be 0.5 moles. 0.5 moles. This is question number 1. Next question number 2 based on this. Question number 2. Calculate, is model number 2. Calculate the volume strength of hydrogen peroxide. Calculate the volume strength of hydrogen peroxide solution if calculate the volume strength of hydrogen peroxide solution for, not if, it is for 0.2 molarity of its solution, for 0.2 molarity of its solution, of its solution. So when they are given molarity, volume strength is equal to, volume strength is equal to molarity into 5.6. So that is equal to 0.2 into 5.6. So the answer will be that. This is called the volume strength. Suppose if they are given normality, if they have given normality, so if I'm molarity, it is 11.2. 0.2 to 11.2, and for if they are given normality, that is 0.2 into 5.6. That's all. Just we have to multiply given normality solution into 5.6. This is the numerical. So very, very important this model also. So to find volume strength of hydrogen peroxide when the molarity of hydrogen peroxide is given. When the molarity of hydrogen peroxide is given, we can find volume strength by using the formula volume strength is equal to molarity into 5.6 and so 11.2. Volume strength is equal to molarity into 11.2, and suppose if they are given normality, volume strength is equal to normality into 5.6. Volume strength is equal to normality into 5.6. So these are the two formulas. So first we need to find, suppose if they are given grams and all, then we can find normality and then we can find volume strength. So easily we can do it. So this is question number 2, model number 3, model number 2. Next we'll see question number 3. So how to calculate question number 3, let us see now. $200 ml of acidified 200 ml of acidified 3-normality hydrogen peroxide, 3-normality hydrogen peroxide is reacted with potassium permanganate solution, till there is a light range of purple color, light range of purple color. Calculate the volume of oxygen produced at NTP. Calculate the volume of oxygen gas produced at STP. So for this, I'm writing the solution here. So please make a note. Very, very important model. This is for advanced JE means, not only JE means, they give for JE advanced only. So first from the given equation, we can say 3 normality of hydrogen peroxide is equal to 5.6 volume of oxygen gas, because normality is given means oxygen is 5.6 liters. 5.6 volume of oxygen gas. Sorry, for one normality. For 3 normality, of H2O2 means equal to 3 into 5.6, because normality into 5.6 is volume strength of hydrogen oxygen gas, which is equal to 16.8 volume of oxygen gas is obtained. Volume strength of oxygen is nothing but volume of oxygen gas obtained. So volume of oxygen gas obtained, volume of oxygen gas produced, volume of oxygen gas produced by H2O2 at STP is equal to volume of oxygen gas into volume strength of hydrogen peroxide into volume strength of hydrogen peroxide. So it is equal to, so volume of oxygen is fed 3 now. So volume of hydrogen peroxide into volume strength of hydrogen peroxide. So it is volume of hydrogen peroxide is 200 ml into volume strength is 16.8. So it is equal to 3360 ml. So 3360 ml of oxygen gas is produced. So same volume of KMnO4 is also produced. So total volume becomes 6.72 liters. The same volume for KMnO4 also. Same volume for potassium permanganate also. So therefore, volume of oxygen is equal to 6.72 liters. Like this question is very, very important. So to find volume of oxygen gas produced is equal to volume of hydrogen peroxide into volume strength of hydrogen peroxide. Volume strength is 5.6 into 3, that is equal to 16.8. and volume of hydrogen peroxide is given 200 ml. So 200 into 60.8, 3360 ml. So this is equal to same volume for potassium permanganate also. So volume of oxygen is equal to total 3360 plus 3360, which is equal to 6.72 liters. So like these questions are important. Next concept, we have uses of hydrogen peroxide. Uses of, no, before going to uses, I would like to teach structure of hydrogen peroxide. Structure of hydrogen peroxide is also very important, because from structure also they ask questions. So let us see structure of hydrogen peroxide. Hydrogen peroxide has a non-polar, non-linear structure. Non-linear structure, since its dipole moment is equal to mu is equal to 2.1 dBies. So exercise states reveal that hydrogen molecule has also indicated that non-polar non-linear structure in which two HO bonds are asymmetrically distributed. Asymmetrically distributed. So it has like asymmetrically distributed in which two oxygen atoms are considered to be are considered to be lying on the spine of a book. Lying on the spine of a book. So with an angle of 90.2 degrees, 90.2 degrees dihedral angle. So it is just like open book like structure. Open book like structure. Open book like structure. Hydrogen peroxide is just like open book like structure. You can see the hydrogen peroxide structure diagram in the textbook. Next we have uses of hydrogen peroxide. Then we'll discuss MCQs based on hydrogen peroxide. Then we'll do summary of the chapter. So now uses of hydrogen peroxide, important use of hydrogen peroxide. Let us start now. So hydrogen peroxide is used in the industries. First one is used in the industries as a bleaching agent for textiles. It is used as a bleaching agent. First one. In industries, it is used as bleaching agent in industries. Point number 2. It is also used as disinfectant. Hydrogen peroxide is also used as disinfectant for domestic purposes. Disinfectant for domestic use, to clean bathrooms, etc. Also called as bathroom cleaner. Next, hydrogen peroxide is used as a good oxidizing agent. Is used as good oxidizing agent in the lab because it oxidizes many compounds. And finally, it is used as a propellant, propellant or fuel in submarines of rockets, or fuel in submarines and rockets. So these are the main uses of hydrogen peroxide. These are the main uses of hydrogen peroxide. It is used as bleaching agent in industries, disinfectant for domestic use, oxidizing agent, and as a propellant or fuel in submarines and rockets. So these are the main use of hydrogen peroxide. So with this, we have completed the explanation part of this chapter. So completely we have done the explanation part of this chapter. Now we'll do questions based on MCQs based on hydrogen peroxide, MCQs on hydrogen peroxide properties. So this is the last concept in this chapter. Then we can wind up this chapter. So please note down all the important questions of hydrogen peroxide. So question number 1, MCQs. The volume strength of the volume strength of 1 normality hydrogen peroxide solution is 1 normality hydrogen peroxide solution is option A, it is 4.8, option B, it is 5.6, option C, it is 8.8, and option D, it is 8.4. So it is nothing but answer is 5.6, because volume strength of hydrogen peroxide is equal to volume strength is equal to volume strength of hydrogen peroxide is equal to normality into 5.6. So answer is 1 into 5.6, which is equal to, because they have given 1 normality, so it is equal to 5.6. That's all. Next, question number 2. Question number 2. Hydrogen peroxide cannot act as a hydrogen peroxide cannot act as a option 1 oxidizing agent, option 2 is option B, dehydrating agent, option C, reducing agent, and option D, acid. So straight away we can say hydrogen peroxide can be used as reducing agent, oxidizing agent, we already know that. Next we have hydrogen peroxide can be used as reducing agent, oxidizing agent, and it cannot be used as dehydrating agent, because the answer is dehydrating agent. It cannot be used as dehydrating agent because sulfuric acid, and it can be used as acid also. So next question, question number 3. So question number 3, now you see this is previous JEE mains question, JEE advanced question actually. From the following statements regarding hydrogen peroxide, which are the following statements? Which are the following statement? Which are the following statement is incorrect? Is incorrect regarding hydrogen peroxide? Option A, it can act only as an oxidizing agent. Option B is JEE Advanced 2015 question. It decomposes on exposure to light. It decomposes on exposure to light. option C, it has to be stored in plastic bottles. It has to be stored in plastic or wax lined glass bottles or wax lined glass bottles. And option D, it has to be kept away from the dust. It has to be kept away from dust. This is JEE Advanced 2015 question. You can see here. JEE Advanced 2015 question. We have to identify the incorrect statement. So simple. It is first option only because hydrogen peroxide acts as an oxidizing agent as well as reducing agent. So it acts as oxidizing agent as well as reducing agent. So the first option is only as an oxidizing agent is wrong. Decomposition or exposure to light is 100% correct. It has to be stored in plastic or wax lined glass bottles. This is also correct. It has to be kept away from dust also. It is 100% correct. So answer is only first option. So next question number 4. Question number 4. The oxide. This is also JEE advanced question. The oxide that gives hydrogen peroxide, that gives hydrogen peroxide on treatment with dilute acid is on treatment with dilute acid. This is nothing but preparation of hydrogen peroxide. Dilute acid is option A is lead dioxide. Option B, it is sodium peroxide. Option C, it is manganese dioxide. And option D, it is titanium dioxide. So easily you can say the answer. This is answer sodium peroxide because sodium peroxide on reaction with sulfuric acid forms sodium sulfate plus hydrogen peroxide. So from peroxides only we will get hydrogen peroxide. The oxygen state of oxygen in hydrogen peroxide is -1. This already we know. Next question. So like this, based on preparations, they'll give questions. In which of the following reactions? In which of the following reactions hydrogen peroxide acts as a reducing agent? Hydrogen peroxide acts as a reducing agent. First reaction, let us write H2O2 plus 2H plus. This is also JEE advanced question. Plus 2 electrons gives rise to 2H2O. So gaining of electrons takes place. Second one, H2O2. On losing 2 electrons, it forms O2 plus 2H plus, losing of electrons. Next, hydrogen peroxide. On gaining 2 electrons, it forms 2OH minus. And fourth equation, let us write hydrogen peroxide plus 2OH minus 3 electrons gives rise to O2 plus 2H2. It's very typical question. So options here, first option A, both 2 and 3, both 2 and 3. Option B, both 1 and 3. Option C, 2 and 4. Option D, 1 and 2. So these are the options we have. So it is more than one correct option because they have made it as one option only. Very important. So hydrogen peroxide is acting as in which of the following reactions hydrogen peroxide acts as a reducing agent? In which of the following reaction hydrogen peroxide acts as reducing agent? So reducing agent means gaining of electrons should be there. So it is. So if you send these to that side, reducing agent means it brings about oxidation to others. Reducing agent means what? It brings oxidation to others. Oxidation reactions only. Oxidation to others. Sorry, reduces reduction to others. Sorry. It brings reduction to others and itself getting oxidized. Reduction to others. So let us see now. Option 2, hydrogen peroxide changes to oxygen plus 2H plus. So it is undergoing reduction because hydrogen peroxide itself is gaining electrons. So losing of electrons and itself getting oxidized. So option 2 is correct answer. This is 2 is correct. And let us see fourth one. Here also minus 3 electrons. So plus is not a reducing property. So 2 and 4. So option C, very important question this is. So option C, hydrogen peroxide gains 2 electrons here and loses 3 electrons here. And that side is forming oxygen plus water. So what is a reducing agent will do? A reducing agent will bring reduction to others and itself getting oxidized and itself getting oxidized. So hydrogen peroxide is oxidized here because it is giving oxygen. So here also it is giving oxygen. So that's why the answer is 2 and 4. Very important question. This question number 5 is very important. It has come for JEE Mains 2014 question. Next question. Question number 6. Question number 6. Let us see now. So like these questions based on hydrogen peroxide will come. How it is acting as reducing agent, how it is acting as oxidizing agent. So simply you can see even the oxygen state of oxygen in the both cases. Oxygen state of oxygen in both the cases. Next question. Next. A 50 ml solution of hydrogen peroxide. A 50 ml of solution of hydrogen peroxide liberates 1.27 grams of iodine. 1.27 grams of iodine from acidified potassium iodide solution. Potassium iodide solution. The percentage strength of hydrogen peroxide is the percentage strength of hydrogen peroxide is option A is 11.2, option B is 5.6, Option C, it is 1.7, and option D, it is 3.4. So this is the question. Very, very important model. This is also. So let us start the solution for this now. They have given solution 50 ml solution of hydrogen peroxide. 50 ml solution of hydrogen peroxide is liberates 1.27 grams of iodine. Liberates 1.27 grams of iodine from 50 ml. Here the question is again, I'm repeating the question. Sorry, it is 5 ml. That's what I'm thinking now. It is not 50 ml, it is 5 ml. A 5 ml solution of hydrogen peroxide liberates 1.27 grams of iodine from an acidified potassium iodide solution. Acidified potassium iodide solution. The percentage strength of hydrogen peroxide is, they are asking us to find the percentage strength of hydrogen peroxide. So let us see the answer now. I'll write the solution here. Just make a note of this. So hydrogen peroxide, write the solution with blue pen. So hydrogen peroxide, equivalent weight of hydrogen peroxide is equal to potassium iodide equal to iodine, because gives 1 mole, 1 mole. So milli equivalent of hydrogen peroxide is equal to milli equivalent of hydrogen peroxide is equivalent to 5 into normality, because 5 ml of volume into normality. So that is 5 normality. So milli equivalent of iodine is equal to, by this you can say milli equivalent of iodine is equal to weight of iodine by equivalent weight of iodine into 1000. So which is into 1000, which is equal to 1.27. That is weight of iodine is 1.27 grams by equivalent weight of iodine is 127 grams, because molecular weight of iodine is 127 into 1000, which is equal to 10 milliequivalents. How much it is? 10 milliequivalents. So by this you can say 10 milliequivalents, because iodine molecular weight is 254, equivalent weight is molecular weight by 2, that is 127. So by this you can say 5 into normality is equal to, because milliequivalent of H2O2 is equal to 5 into normality is equal to milliequivalent of iodine, that is 10 milliequivalents. So by this you can say therefore normality is equal to 2. Normality is equal to 2. So 1 normality of hydrogen peroxide is equal to 1.7% of volume strength of hydrogen peroxide. So therefore 2 normality is equal to 3.4 percentage of volume strength of hydrogen peroxide. So answer is 3.4. Very, very important question. So like these questions are expected for entrance exams. So answer is 3.4 percentage. So now we'll write the summary of the chapter, because this is a questions based on hydrogen peroxide, and remaining topics we have done already questions. So summary of the chapter right now I'm doing now. Summary of the chapter. First we have dihydrogen, preparation, comma, properties and uses. Second topic we have water, hardness of water. Next, deuterium oxide. And finally, degree of hardness of water. Degree of hardness of water, degree of hardness of water. So next we have hydrogen peroxide preparation, comma, properties and uses. Preparation, properties and uses. So these are the three topics we have in this chapter. Very, very simple, small chapter. And from this chapter, definitely you'll get questions. So first is 2 star and second topic is 3 star. Compulsory you'll get a question based on second topic and third topic, because from degree of hardness of water you'll get numericals. From hydrogen peroxide preparation, properties and strength of hydrogen peroxide, use of hydrogen peroxide, you'll get a questions. And dihydrogen preparation properties, only in this we have syngas, that is water gas synthesis. Water gas is most important. So all these three topics, if you could do all the models what we have done, and if you see the BPDs and you see the notes and listen to the class properly, easily you can solve any questions from the any material of competitive books. So I hope it will be helpful for you. This chapter is more helpful for you. Definitely you'll get one question from this chapter. Very, very important chapter and it's most important. So So you have to focus more on topic 2 and topic 3, because you will get questions from topic 2 and topic 3. Because from previous year's questions, if you see, you will get questions based on hardness of water and how to how to make it soft by using permanent hardness of water and temporary hardness of water. That is Calgon method, Gauss permitted process, ion exchange methods, and even organic reactions also. And coming to softness of water, degree of hardness of water, you'll get numericals based on this, which you have done in fourth lecture. And coming to hydrogen peroxide, we have to know about its preparation, how it is prepared from barium peroxide, sodium peroxide, etc., and its chemical properties and uses, and also strength of hydrogen peroxide is also important. Strength of hydrogen peroxide numericals. Strength of hydrogen peroxide numericals is also very, very important. So if you could concentrate all these things, easily you can score question marks in this chapter. Definitely you are going to get one question from this chapter for the entrance exam. So please follow what we discussed. With this, I'm ending this session. Thank you all.